Welcome back. Let's look at the homework 1, math review and algorithm analysis. So the first part of this is just a review of common math functions. I'd just like you to plot these math functions. I recommend you use Excel. It's really important that you learn Excel or a tool like Excel. You can do a whole bunch with it. Okay, so plot those and then rank them. That is, say which one is growing the fastest, right? And indicate on your plot somehow which one is growing the fastest. Also, put the closest common big O curve next to it. That is, which one is big O of n, which one is big O of 2 to the n, and basically 2 to the x is going to be the 2 to the n. So it's a fairly easy problem here. I just want you to get familiar with a graphing tool because we're going to be needing that, and I want you to review the math that you've. It may have been a while for some of you since you've seen that stuff. All right. The second concept that on this homework is using empirical analysis, so or counting the work. So I've got several functions, and each one of these functions has a different time complexity. There's foo1, foo2, foo3 down there. So I just want you to call this function repeatedly for different values of n. So the easiest way to do that is write a loop around this guy, right? So make a for loop in main, right? Make a for loop in main where n goes from 0 to 64 and call this function repeatedly, right? So you'll call this function with n equals 0. It'll run around in here and the counter will increment. You'll get a return value, right? And then put that return value in a table. Once again, I would use Excel. Okay, then this will get called again for 1, right? You're going to take this function and put it inside of a loop, right? So it'll get called again for 1. It'll run around in here and you'll get another return value. And then it'll get called for 2 and you'll get a return value. And you'll get all these return values and then put them in this table over here. Okay, and then plot that. Okay, and you'll get a curve that's going to be similar to one of the big O curves. Okay, so this guy here you're going to get a curve for, and then this foo2 you're going to get a curve for, and foo3 you're going to get a curve for. Once again, call each one of these from a loop in main, right? So you have main, you have a for loop, and then inside that for loop you'll call foo1. Then do that again for foo2, and do it again for foo3, and do it again for foo4, okay? And you'll get these different curves. Okay, this last guy here, the hint is it's going to have a bad time complexity. For small n, you'll get some reasonable numbers, but as n starts getting, 20, 30, close to that, the return value here is going to be very, very large. So, don't wait all week for your computer to execute for n equals 64. Just cut it off at some reasonable n number and state on your homework that it was getting to take a long time. Okay. Then I'd like you to graph all of those guys, and then indicate on the graphs which one is the worst one and which one is the best one. All right, then I'd like you to do some iterative solutions. So I'd like you to implement the iterative solution for this classical arithmetic series. Just want you to, it's just a simple loop. I just want you to produce these values and make a table of the result of this series for different values of n. Okay. Then do that for a geometric series. This is a nested loop. Make a nice little table. So what is the point of this? Well, it's to get you thinking what's arithmetic and what's geometric, and to help you remember that, because we're going to be seeing that kind of stuff later. A lot of the material in this course, it all kind of reinforces each other. After a few weeks, after a month, 6 weeks we'll have a vocabulary that we can be using, and we'll be seeing a lot of the same themes over and over again. It's kind of cool, I think. All right, this is a geometric series. It's going to have a certain time complexity. What do you think? We've talked about our rules of thumb in earlier videos. Let's apply those. So this outer loop is n times. The inner loop is, roughly speaking, n times. J is going from 1 to I, and I is increasing. So we can, worst case, call this inner loop n, worst case. So worst case n inside of n is n squared. Okay, so this is an n squared algorithm. Okay, it's possible to do this very same series in n time. Just n time. Not n squared time, but n time. And so I want you to think about that. I want you to think about how you could change this stuff in here to get rid of this inner loop. It can be done, okay? So work on that. The point being, I mean, there's multiple solutions for any problem, and this solution right here is n squared, but there is an n solution. There's also a formula, right? Which would be big O of 1, would be constant time. So I want you to be thinking about that, doing something to think about that. All right, then here's just a crazy series. I want you to come up with some loops that do this. Okay, for all of these loops, I want you to tell me what the big O is, which I pretty much told you already in this little video, but just say that again in your own words, okay? And you could describe the rules of thumb that you're using, and or whatever, but just say what the big O is, and so list your big O answer and explain why it is so in English. Okay? Just a little introduction to some basic math formulas that we're going to see throughout the semester, some a little empirical analysis with some counters to get some curves, a little plotting, a little thinking about different kinds of solutions to the same kinds of problems down in here, and a little bit of a practice using some rules of thumb. Okay, we're going to be using these techniques throughout the whole semester on all kinds of data structures with all kinds of different algorithms. All right, put this all together into a nice document. See the document formatting standards file that's posted earlier. Look at the homework 0 video that talks about how to format stuff. Make it look pretty, okay? Neatness absolutely counts. All right, thanks. See you next time.